Okay, when we move on to writing equations, it's going to use the same information that we've been using. So vertical asymptotes, if we have a list of vertical asymptotes, those are coming from our denominator. So that's going to tell me what factors I have in the denominator. Okay, x-intercepts, those come from my numerator. So those are going to tell me what factors I have in the numerator. And then horizontal asymptote, if I have one, that's going to tell me either what the leading coefficients are, or if it was approaching 0, that would tell me that I need to have a larger power in the denominator than I do on top. Or if they told me that there was no horizontal asymptote, then I would know that I would need to have a larger power on the top than what I have on the bottom. So I'm actually going to do all three of those cases with these same asymptotes and intercepts, just so you can kind of see how you can adjust your function to meet different end behavior. So we'll start with the basics. I know I need vertical asymptotes at 2, 5, and -4. So that means my denominator is going to have factors of x minus 2, x minus 5, and x plus 4. I have intercepts of -1, so that means on the numerator I need x plus 1 as a factor, x minus 3, and x minus 8. I have a horizontal asymptote at 9/2. So in order to have that horizontal asymptote, my largest, I have to have the same number of x's on top as I do on the bottom, because this would turn out to be an x cubed equation, and this would turn out to be an x cubed equation. And that means that I need to have, I'm just going to copy this real quick so that we can show some other examples. Okay, so if I need to have 9/2 as a horizontal asymptote, that means my leading coefficients need to make 9/2 as their ratio. So this would be one equation that meets these criteria. And that solves that question. Let's say they didn't give us this asymptote. Let's say they told us that there were no horizontal asymptotes. Well, in order to have no horizontal asymptotes, I need to have a higher number of x's on top than I do on the bottom. I can't add some other 0 in here, though, because these are the only zeros that are listed. So I couldn't just put another x, because then I would have a 0 at 0, which isn't one that's listed. What I could do is I could make one of these a double 0. Okay, I could square this. Now I'd have a 4th degree polynomial on top and a 3rd degree polynomial on the bottom. And that would take care of my function not having a horizontal asymptote. If they told me my horizontal asymptote had to be at 0, that means I need a larger degree polynomial on the bottom. So in this case, I'm going to, double or triple, or I just need to make more x's on the bottom. So I could square one of these. I could square 2 of them or 3 of them, or I could make 1 to the 5th power if I wanted. But I need to have more x's on the bottom than I do on the top. And that would solve that problem. So writing rational equations that meet certain criteria is probably one of the easier parts of this chapter.